Hello, and welcome to this demonstration of extracting ICCs in R using the ICC Loop program that we developed here at Biostat Global Consulting. ICC Loop extracts intercluster correlation coefficients, design effects, and other interesting parameters from survey datasets. It loops through different outcomes of interest and different subsets of the data, so it has the potential to calculate multiple ICCs for a single survey dataset. In this brief presentation, I'm going to walk through what you need to run ICC Loop on your own computer. I'll give a demonstration of how you might adapt the demo materials that we've already shared in order to run ICC Loop on your own data. And then we'll briefly look at the output of the program, a data set of ICCs and other parameters, as well as organ pipe plots, which visualize how sample proportion varies across clusters. We're going to get started by looking in the Dropbox that we've shared, which has a folder called Resources for Working in R. We'll open that up and then we'll open the folder called Demo. These two demo folders have the same programs in them, they just work with different types of input data. And from this folder, I'm going to grab the Programs subfolder. I'm going to grab this Demonstrate ICC Loop R script, and for convenience, I'm also going to grab this R project. I'm going to copy those files, and then I'm going to move over to the Documents folder on my own computer where I'm going to do this analysis and create a new folder, which I'll call Extract ICCs. And then in this folder, I will paste those files that I just grabbed from the Dropbox. In this folder, I'm also going to put the data set that I want to analyze. So this is faux data from the land of Oz for an SIA measles campaign. I'm going to drop that faux data set in this folder as well. The next thing I'm going to do is open this R project. Before I do that, I'm going to give this R project a clearer name, since we're no longer working with the demo Harmonia data. And then I'm going to open this R project. What opening an R project does is it opens an instance of R with a working directory that points to the folder where that R project sits. So if I type getwd in my R window here, I see that my working directory is this extract ICCs folder that I just created, where this R project is sitting. This is sort of a convenient pin for where I want to do my analysis, where my input files are sitting and where my output files will go. Now I'm going to open up this Demonstrate ICC Loop R script, which is what we're going to be editing. This ICC Loop script is designed to work with the Harmonia example datasets that are in the Dropbox, and I'm going to edit this to work with a different dataset. The first few lines of this script just install some packages. I already have them on my computer, so I'm going to skip those install statements, and I'm just going to load up some packages. If you are not working in an R project and you want to set your working directory to the folder that you want to work in, you would do that by uncommenting this line and setting that working directory to the correct file path on your machine. Next, I'm going to source some programs that sit in this programs folder. The main one is ICC Loop, but ICC Loop also calls these other two functions calc-ICC, which calculates intercluster correlation coefficients and generates a confidence interval, and then OP-plot, which generates organ pipe plots. For convenience, I'm going to set some file paths. The base path I'm going to define as my current working directory. I'm going to get rid of TT path and RI path. Those were paths to some example Harmonia datasets, but we're only working with one SIA dataset in this demo. So I'm going to create something called SIA path that is the full file path to the dataset that I'm going to analyze. It's going to replace this dataset name with the dataset that I'm working with, which is Oz SIAMR.RDS. So SIA path here is just the full file path to this dataset. And then I'm going to read that data into R. So I'm going to get rid of this statement, which I don't need, and I'm going to create an object called my data, and I'm going to read with the read RDS command the dataset that's sitting at SIA path. So I've read my data in. It's got about 38,000 observations on 10 variables. We'll take a quick glimpse at that to see what we're working with. We have a 0-1 outcome variable called got SIA dose that indicates whether the child in this row received the campaign dose. In this example, that dose would be measles. Then we have a few variables that identify clusters, strata, and survey weights in this data set, and a few IDs indicating which country, which province at level 2, and which health district each observation falls in, and then also indicating whether the cluster is urban or rural in each of these cases. So let's start out by running ICC loop at level 1, so an analysis for the entire country. There are a bunch of different arguments to ICC loop. If you open up the ICC loop function, at the top of this function, you can see all of the arguments, the ones that are required every time that you run the function, and then arguments with the default value, which you only need to specify if you want to use something other than the default value. The ID and the row arguments are something that we'll provide for you. These are identifiers for your particular survey that help us keep these surveys organized internally. In this example, I'm just going to say ID is 0 and row is 0. But again, we'll provide these for you if you're doing your own analysis. The next argument is data. This is the data set that you've read into R that you want to analyze. We called that object my data when we read it in above. And data path is the file path to that data set. We use this for data management purposes to make sure that we always know which data set is analyzed in each row of the output data set. And the ICC loop program also uses this path to determine where to save the output of the program. So we call data path SIA path above when we defined it. Outcome is the outcome variable that we're interested in. There's only one outcome variable in the my data dataset. It's called got SIA dose. If you wanted to supply multiple dependent variables to look through, multiple outcome variables, we could provide those in a concatenate statement. So if you had an outcome called outcome 2, for instance, we could specify that here. But we don't need to do that in this case. We're just going to specify got SIA dose as the single outcome that we're interested in. Our strat bar is the variable that we want to stratify by. We're just going to do an analysis for the whole country, so we're just going to stratify by level 1 ID. Now, level 1 ID in my data is just a number. It's not very descriptive. Level 2 ID is accompanied by a level 2 name, which indicates the name for each of these level 2 strata. Same for level 3 ID. But there's no variable called level 1 name in this data set. So we might want to create that just for some clarity in our output. So what I'm going to do is I'm going to create a new variable in my data. I'm going to call it level 1 name, though I could call it whatever I wanted. And this is the same for every observation in the data set. Every observation belongs to the same level 1. So I'm just going to say that they all are in the country of Oz. So for the strat var, I specify level 1 ID, and then I'm also going to specify this accompanying strat name var that is the variable that holds the names for the levels of the strat var. And that's going to be level 1 name. That's not going to change here. I'm going to save my output to a data set called SIA ICCs. Strat level indicates the level of stratification. We use 1 for national results, 2 for subnational results, and 3 for sub-subnational results. So our strat level here is 1 because we're working at the national level. And then stratum ID, cluster var, and weight var are arguments that tell us some important information about the survey design. So these are the variables in your data set that hold the identifiers for strata, clusters, and survey weights. By default, ICC loop looks for variables called stratum ID, cluster ID, and PS weight. If your variables are named something different in your data set, you'll need to change these arguments. So in my data, our cluster ID is called clust, our stratum ID is called strat, and our weight variable is called weight. So cluster here is clust, stratum ID strat, and weight var is weight. Our data set is not self-weighted. If it were, we'd specify self-weighted equals true. The age group for this survey is 6 to 59 months. So here you would just leave a a note about what age group this survey pertained to. For the comment, we're going to specify which dose the SIA was providing. So in this example, I'm calling that dose MR. And then the replace argument specifies whether you want the results of this run of ICC loop to be saved as a new data set, overwriting any previous results, or whether you want those results appended. Because we don't have anything called SIA ICCs in this output folder, it doesn't really matter what we specify here. But since this is our first run of ICC loop for this data set, our practice is to specify replace equals true. The default value for the replace argument is false. So now we're all set up. I'm going to run ICC loop. And this is going to take a couple of minutes. The main thing that takes time is that our process for getting a confidence interval for the intercluster correlation coefficient is to bootstrap with 1,000 replications. So we resample clusters with replacement, calculate the ICCs, and we get this vector of 1,000 ICCs from those resampled clusters. And then we use that vector to create a 95% confidence interval. Because this process is a little slow, I'm going to take a short pause and I'll be back with you in just a moment. All right, and that run of ICC loop on my computer took about 2 or 3 minutes. We finished with this warning message, which is normal. One of the calculations that we do inside ICC loop is a design effect with no stratification and no weights. In order to do that, we specify a survey design that doesn't include weights, and the survey package gives us this warning message to make sure that we did that on purpose. We did. We only did it for this one calculation. So finishing with this warning message is normal. If you run ICC loop and you get any warning messages other than this or anything that you don't understand, we're happy to talk about those results with you. While that was running, I cleaned up this demo file a little bit, removing some of those other calculations on other data sets below in the script here. So I'm going to run ICC loop one more time, and I'm going to use a different strat bar. So we used level 1 ID for our first run. Now we're going to do something with more than one level. So for the strat bar here, let's stratify by the variable urban rural. So in my data, urban rural takes these text values, urban and rural. It's different from something like a pair of variables like level 2 ID and level 2 name, where one is numeric and one contains the value labels. Urban rural just has those value labels. So we can specify a numeric strat var and a character factor name variable if we want to. But the R program for ICC loop is perfectly happy just taking a stratification variable that has the names of the different levels. So in this case, we're going to specify urban rural as the strat var, and we're not going to specify a strat name var at all because the names are already in urban rural. We're saving to the same output data set, and we're going to say replace equals false because we want to append the results of this run of ICC loop onto this data set that we've already created with the level 1 results. So our outcome is the same, our strat bar has changed, our output data set is the same. Our strat level is going to be 2 for subnational results because now we're splitting into urban and rural. The stratum ID, cluster ID, and weight variables are the same. Our data set is still not self-weighted, our age group is the same, and our comment is the same. So now we're going to run ICC loop a second time. And after a few minutes, that second run of ICC loop is done. So let's take a look at some of the output here. Our output data set is SIA ICCs. So I'm going to go ahead and load that into R and take a look. We have our survey and row IDs. Again, those are things that we'll supply to you. We have the path to the data set, which you supplied in the data set name that helps us keep track of exactly what data set was analyzed. The age group for this survey, the outcome name, different levels of these strat bars, and the name of the level being analyzed in this row. We have an indication of the name and the path to the organ pipe plot pertaining to this row. We calculate the number of clusters, strata, and respondents in each of these rows, the average number of respondents per cluster, as well as the weighted average, the standard deviation, and the minimum and maximum of respondents per cluster. the number of clusters with 100% coverage, the number of clusters with 0% coverage, the proportion estimate, the standard error and Wilson confidence interval around that estimate, the design effect and effective sample size, as well as the design effect if the survey design had no stratification and no weights, the coefficient of variation on weights, the intercluster correlation coefficient, and its bootstrapped standard error, some components of the ICC, mean squared between and mean squared within, our comment about what dose was covered in this SIA survey, and then a few other confidence intervals around our proportion estimate. So Logit, Agresti, Kuhl, Klopper, Pearson, Fleiss, Jeffries, Wald, and then Wilson, which is our main confidence interval reported earlier. Let's also take a look at the output images, which are these organ pipe plots. They get saved in a new folder called plots op_r. We have 3 organ pipe plots to go with the 3 rows of the ICC dataset. This is all of the clusters in the dataset at level 1. Then the clusters looking just at the rural subset, and then clusters looking at the urban subset. Each bar here is a cluster, and its proportion is represented by the height of the bar. The red dotted line indicates the number of respondents in each cluster, as indicated by this secondary y-axis. When you share your results with us, what we ask that you share is the output ICC's dataset, as well as this folder of organ pipe plots. We have more detail on program inputs and outputs in the ICC calculation guidance document in our shared Dropbox. And that brings us to the end of this presentation. We are happy to talk with you if you have any questions about the ICC programs. We're happy to share a screen and help you troubleshoot any issues that you run into if you run these programs on your own. So our email addresses are here. You can get in touch with me, particularly if you have any issues with the R programs themselves, but Dale and I are happy to talk to you about any questions that you have. Thanks so much for joining us, and we look forward to hearing from you.